Let's see. All righty, looks like I'm up and running. Hopefully you can hear this. Just going to get some problems in front of us so we can start discussing something. Begin that whole process of trying to create a working knowledge in this discipline. Not a memorized one, not something that just kicks back something for a test, but an actual working knowledge so that whatever we talk about today, next year, you still remember it and can work with it. That's vastly different than sticking with one topic and looking at, oh, I put this number here and that number there, and oh, I write that out on a test, and then we move to the next topic 2 days later. Well, we're not doing it that way. Everything that I'm talking about today is going to be on every test the whole year. And what might take you 2 or 3 days to sort through and then be able to do, it might take you a minute or two to do a problem. Hopefully a month's time from now, the things I'm talking about today take you 5 seconds. All right, so that's a working knowledge. There you go. Write the equation of a line from 2 points. Boom, just write it. You understand why you're writing it. And hopefully as you keep writing it, you'll get a deeper understanding of what you're working with. And we're going to try to do that with every topic that we cover. And I'm going to give you all the time in the world to learn from your mistakes. So no one test is all that important. I guess I'm saying this as much now because I haven't met you. Okay, half an hour from now, you should be coming into the classroom and we'll be talking about the same things. All right, so let me get at this worksheet because half an hour from now, you are coming into the classroom. And so I'd like to get maybe 10 problems in front of you so that tonight you look at them. I think I'm going to give you the exact same worksheet tomorrow when you come into class. And we can jump to the board a whole lot quicker. And we'll just keep tacking on. Hey, here's some more math. Let's do some more math. All right, so how do you write the equation of a line that passes through 2 points? I'm assuming we got to that. I'm assuming we're going to get to that after our introductions. So hopefully this isn't the first time you're going to hear this, but I'm going to treat it as if it was the first time. No, I'm not going to treat it as if it's the first time. All right, because I got a half an hour and I got 10 problems, so let me get at it. All right, so -9 is the next value. Making a statement like that, it's gone. That number's now gone. And if I want to turn it into some other number like -2, I put parentheses around it. It's kind of helpful. So let me put -9 in right now. -9 plus 9 is 0, but I want -2. So why don't I write -2? Oh my goodness, I got a marker. I'm doing math. So I just made a correlation where that x gets that y. And now I want this x to get that y value. And we'll talk about it more than this. So, from the mechanical standpoint, but all right, so I drop a 5 in. So what happens when I drop a 5 in? I get 14 minus 2, and I want to see if that actually equals 3. And I don't think it does. So this number needs to change. So I can't use addition and subtraction anymore because that would louse up the correlation in the first x and y. So how do I get rid of number 14? Well, I could cancel it like that. I got a marker. It's gone. And then I can figure out what -2 gets me 3. And I think that's 5. So let's see, 5, 14. So we put a -9 in. Let's see if we get the right y value. -9 plus 9 is 0. That's the critical number. -9 is the critical number because 0 times anything is 0. -2 works for that. And let's drop the number 5 in. 5 plus 9 is 14. All the 14s cancel. And 5 minus 2 is 3. It works for that. I guess that's how you can write the equation of a line quickly. Of course, being a math problem, the history of this is writing y on the left side. And of course, being a math problem, that's the easiest way to write the equation of a line, and that's the one that's not taught. Go figure. We're teaching it right now, though, because it's going to help us when we get into more complicated problems. All right, so that's how you write the equation of a line. Now, I think we have y since it's been given to us in this fashion. I suppose if you can take 2 points and write the equation of a line, then the next thing to ask is, can you see the 2 points that are being highlighted here? you have a choice of plugging in an X value here. And I'm hoping that you're already starting to think about what's the easiest one to work with. Well, if you said 1, you would have been right. 1 minus 1 is 0, and 0 times anything is 0. Minus 5 gets me a correlation. And the question is, what's the next easy correlation? Well, if you're dividing something by 4, then I would think the multiples of 4 would be the easiest thing to pick. So on and so forth. And it's easiest to pick positive numbers, but there's nothing preventing us from extending our understanding to negative numbers. Those are the easiest numbers to divide by 4 because you've worked with them the most. Now, so the question then is, we've already made this one, right? Putting in a 1. So probably 4 divided by 4 would be nice. So what makes x minus 1 4? And if you pick the number 5, you'd be right. And so if we put a number like 5 in, 5 minus 1 is 4. The 4's cancel. We'll have to talk about fractional operations more than that, I'm sure. And that gives me minus 3 minus 5, which is minus 8. And now it's time to think about patterns. Ooh, how did I get from minus 5 to minus 8? I went down 3. How did I get from 1 to 5? I went up 4. Minus 3, 4. Oh, that seems to be telling me something. Well, let's go down 3 again. Minus 11, let's go up 4 again. 9. Is this really a correlation? Let's check it and find out. 9 minus 1. Oh, that's 8. Oh, 4 does go into 8. Nice. That's 2. Oh, minus 3 times 2 is minus 6, minus 5. Well, that's minus 11. Oh, yes, 9 got me minus 11. I guess there's something there that we should be thinking about. How these table values are changing. I wonder if you can tell me in the next one. Go up 4. Go down 3. So on and so forth. And we could have gone in the other direction. But we're just getting started here. Just getting started about thinking about, some of the things we're going to be studying in more detail for the entire semester. We're not going to get away from this discussion. Nope, we're going to keep having it until you understand it. All right. So mx plus b. Oh, I erased the equation. So y equals minus 3/4 x minus 1 minus 5, I think is what we started with. And every textbook written seems to highlight writing the equational line in mx plus b form. Some kind of multiplication and a y-intercept. And that's what's really pushed, unfortunately so. And we'll talk about why later. But it's a good experience for you to do the mechanics of that because it forces you to look at fractional rules, which we're just starting to talk about. So step 1, the distribution. And you should have practiced that in all your pre-algebra classes. I don't know if you did or not. Minus times a minus is a positive 3/4 minus 5. And then we want to get good at adding fractions. Adding fractions follows the same rules of adding anything. Whatever you're adding has to be alike. So what are we adding? We're adding numbers that are being divided by other numbers. And the question is, are those other numbers alike? And the answer is no. 3 is being divided by 4, but 5 is being divided by 1. Would be nice if they were both being divided by 4. And we can make that happen. I think that minus 20 over 4 is the same as minus 5 over 1. But now my divisions are alike, so I can put it in slope-intercept form. Minus 3/4 x, 3 minus 20, minus 17 over 4. And eventually we're going to learn how to sketch that. What's the critical number here? If you said 0, you'd be right, because 0 times anything is the easiest multiplication to do. Minus 17 over 4 is near negative 4, so you just locate on a graph 0 gets us minus 17 over 4. And once again, we're doing something you should have covered in pre-algebra, how to plot a coordinate into the Cartesian coordinate system. And if you weren't taught that, no problem. Big part of this course is to fill in any gaps that you have from previous levels of study. And you don't have to learn it today. We have the rule of 4 that I'm sure we talked about in class. Looks like I'm out of practice here. I got to adjust the camera so that you can see everything that I just did. And then minus 3 over 4 tells us how, if we continue this discussion, that number is how the x's change, and we can use a triangle for change. So that this triangle x means change in x. So a change in x is horizontal, maybe 4 units in that direction, and then 3 units down. I didn't do this all that well, but then we can start talking about what graphs are, how we use them, what information we can glean from them. Again, another topic that needs exploration and development. All right, so we'll be doing that tomorrow. You'll come into class and you'll repeat all the problems that I just did, and then we'll do some other ones like it. We had equations. Minus 3/5 x plus 6 equals -2. You may already have been hammered with whatever you do to one side of the equation, you do to the other. So 5 plus 2 equals 7. You may have been hammered with addition of 2 becomes subtraction of 2 on the other side. We're not going to solve problems like that. We're going to see that, oh yes, 5 does come from 7 minus 2. Now that's a very subtle difference in language that I just used from what's traditionally used, because mathematics is about operations and inverse operations. Okay, so what do we learn from a simple statement like this? Addition of 2 on this side could have been expressed as subtraction of 2 on the other, and it's still equal. Okay, so how do I solve a problem like this? Well, addition of 6 becomes what on the other side? If you said subtraction of 6, you would be right. And I hope as we go through the term, you can just do -2 minus 6 in your head. Hoping that's where we get within a week's time. Okay. I see 2 operations here because I'm trying to figure out what x equals. Now let's look at division by 5. 10 divided by 5 is 2. And I'm sure somebody probably drilled into you, multiply the left side by 5, multiply the right side by 5. The scales of justice approach to solving equations. We're not going to do that. No, we're going to look at this and say, you know what? The number 10 comes from 2 times 5. Oh, so what do I learn from that? Division by 5 on the left can be expressed as multiplication by 5 on the right. And now we're not really moving numbers, we're moving operations around with the associated numbers. So what can I do here? Typical Algebra 1 textbook would say multiply by the reciprocal. I think it's easier to say division by 5 becomes multiplication by 5 on the other side. So now can you do that in your head? Can you multiply that number by 5? I hope that you said -40. Okay, that's 5 times that. And now we got multiplication. Well, maybe you've already got lingo down. Multiplication becomes what? Division on the other side. So -40 is going to get divided by -3. And in your pre-algebra, I hope you learned something about dividing a negative by another negative becomes a positive. So the question is, can you see that right here, that you're dividing this into that to get 40 over 3? And that's how we're going to streamline our equation solving as we go through the semester with more difficult equations than that. And you're going to have to be given a lot of time to sort out what you're doing. Okay, so there's no rush here. Just give it your attention, continue to give it your attention, continue to practice, and hopefully this is something by the end of the semester that you look at and say, oh, that's a piece of cake. Now, estimating with a graph. So 40 over 3 is what? near 13. Okay, that's an estimate. It's actually 13 and a third. But so we're near an X value of 13. Okay. So that's what we're going to do. We're going to estimate this graph. All right, so what did we have here? Something we worked with earlier in the video. Slope intercept. Slope intercept, 6 units. We'll call that 6 units. So now I have a ruler. So I'm going to go over 5, which is, maybe that much. If that's 6, maybe that's 5, something like that. Down 3, well, if that's 5 units, down 3, maybe it looks like that. And so we have this collection of data, and obviously you're going to need a lot more practice than this first attempt at doing something. Yeah, but what I basically did is over 5, down 3, and to just a little sketch. Equals -2. Well, if that's 5, and -2 is maybe here, and that's a height of -2. So the question is, what is that X value? We said it's this number. Okay, and here's the x-axis. Right? Here's the x-axis. Does it look like that might be the correct? Yeah, I'd say yeah. Here's 5, here's 10. Right? This is just a really, what kind of graph would I call it? A hurried graph, just to get an estimate. And so I've gotten an answer kind of from 2 different processes. They match up. It's a good way to figure out something's right. All right, so that's what we're going to be practicing in class, and that will be on every test. You take the rest of the term, and your job is to show me that at some point, the next week or 2, that you're starting to process that. All right, so now we got -3x plus 11 equals 2x plus 4. I'll just do this really quickly. Subtraction of 3x is the same as addition of 3x on the other side. Addition of 4 is the same as subtraction. Multiplication becomes division. And so I've got an X value that is just a little bit bigger than 1. All right, 7/5, a little bit bigger than 1. All right, let's confirm that with a graph. So I have a linear function, a linear calculation. Slope intercept form again, I'll call that 11. Down 3 over 1, down 3 over 1 gives me a graph that looks like that. We'll call that line 1. 2x plus 4. That's 11, maybe 4 is in here, rough estimate. Going over 1 and up 2. Huh, yeah, it looks like I have an X value that's positive because this is the origin. What's that X value? Does it look like it could be 7/5? Absolutely does. Getting the same answer from 2 different perspectives. I got a feeling I'm right. How much time do I have here? X plus 5 times X minus 2. Maybe I'll have to stop here. I see students starting to show up. Better check the time. 8:31, yeah. So I only did 1, 2, 3, 4, 5, 6, 7 problems. We'll stop it there. And this is something I hope you've done at pre-algebra. If not, start to explain what's going on there, because you're looking at a rectangle, and your whole high school career in mathematics is going to be looking at rectangles. All right. Don't panic.